In this video, I'll be going over our notes for angles of elevation and depression. So to recall our three trig functions, let's start with that just to remind ourselves kind of what we're going to be doing once we are identifying these angles. So our three trig functions help us find the missing sides or angles of a right triangle, and we remember them using the abbreviation SOHCAHTOA. So this helps us remember what order to put these in. So for the sine of theta, you would put your opposite side over your hypotenuse to get the ratio for sine. For the cosine of theta, you put your adjacent side over your hypotenuse. And for your tangent of theta, you put your opposite side over your adjacent. So we're going to be using these once we identify an angle of depression or an angle of elevation in a real-world scenario and use those three trig functions to help us find those missing parts. So an angle of elevation will be the angle between an object and a line of sight where the angle is above the horizontal line. So if you look at this picture, we can see there's an observer, a person down on the ground here, and from their sight line, which is the horizontal line, if they were to look straight ahead, that's their horizontal line. If they're going to look up at the balloon, we would say that they are looking up at an angle of elevation of 38 degrees. That's what that would say. But if it had read the angle of depression from the balloon to the observer, you'd be pretending that your line of sight is now in the balloon and you're looking down by 38 degrees. So it depends on what you are given. The angle of elevation will be above, so think of like elevate, you're going upwards, or like in an elevator, right? An angle of depression will be below the horizontal line, and so you can kind of think like a depression in the ground is like a little kind of like a dip in the ground or like a surface that's being pushed down. So you're looking downwards from there. So we're going to label those in this photo. So from the top of the mountain, angle 1, if you were standing at the top of the mountain and looking outward, that would be your horizontal line. So angle 1 would be below the horizontal line. So angle 1 is an angle of depression. From angle 2, you are now the observer, you're this person. If you look outward, directly in front of you is your horizontal line of sight. So the angle above your line of sight is the angle of elevation. So angle 2 is called an angle of elevation. But if you were to look down from where you were originally looking out horizontal, that would be your angle of depression. So that's angle 3. And finally, the angle 4 way down here is from the bottom of the house. So if maybe you would say like from the base of the house, the angle of elevation to that person's eyesight. So that would be the angle of elevation because you're looking up above the horizontal line there. So depression is below the horizontal line and elevation is above the horizontal line. So we're going to use these and apply them to some word problems here. In the first one, it says a sonar operator on a ship detects a submarine at a distance of 500 meters and an angle of depression of 40 degrees. How deep is the submarine? So we're going to draw this here. We would say that on the ship, they are detecting a submarine at a distance of 500 meters. So we're going to say this is 500 meters from the ship to the submarine. And it's at an angle of depression of 40. So from the ship, the angle of depression is 40 degrees. So this angle below the horizontal line is 40. So we want to now know, well, how deep is the submarine? We want to know what is this amount of height. So what we can then see is that there's this right triangle forming from where we drop down from the ship to the submarine's depth. So we're going to find out, well, what is this depth? That'll be our x value. Now notice in here, we can see that we don't really know anything besides the x and the 500. This 40 is not in our triangle. So something that we can do to figure that out is we could say, well, the one next to it would need to be its complement. So we would have to say that that's 50 degrees because it's going to have to add up to 90 if we were to make that 90-degree angle. The other way you could look at it would be if you took and said, well, your angle of depression is 40. So if you drop it down over here, if this is your depth, this is still the distance of 500, then you could have it labeled this way. So it's up to you which way you want to view it. If this makes more sense to you, you can do it that way. Or you can do it the way we first drew it and have your angle of depression of 40 degrees to say that the distance to the submarine is 500 meters This drops down and becomes that 90-degree angle, and we're looking for the depth. So this is the angle of 50 degrees that we want that would make up that 90-degree total in the corner. So you have a choice of which way you'd like to do it. I'm going to set it up in this regard for this example. So if I'm using this, that means my theta is up here in the top corner. So x would be the adjacent side, and the 500 is the hypotenuse. So I would be taking cosine here, because the cosine of theta is always your adjacent over your hypotenuse. So the cosine of my angle, which is 50 degrees, equals my adjacent of x over my hypotenuse of 500. To solve for x, we just have to multiply both sides by 500 here. When we do that, it helps us get rid of the 500 in the numerator and denominator. We're just left with our x value. We're going to type this into our calculator, remembering to keep our calculator in degree mode. And if we round to the nearest tenth, we end up at 321 4/10 meters here. In number 2, it says a staircase has an angle of elevation of 28 degrees and covers a total distance of 17 feet. To the nearest foot, what is the vertical height h covered by the staircase? So you can see this picture is already given to us, and they told us that the angle of elevation is 28 degrees. So from the ground up our stairs, we get that angle of elevation of 28 that's marked there. So that'll be our theta. We know that the actual distance of the stairs covers 17 feet, so that's our hypotenuse in this case. And the side h, the height of the stairs that we're looking for, is actually our opposite side in relation to our theta at 28 degrees. The base down here would be our adjacent, but there's no value given to it, and we're not asked to find that, so we don't really need it in this case. So we can get rid of it just to not overcomplicate anything. So now that I'm looking for my opposite and I know my angle and my hypotenuse, I'm going to be using the sine ratio here. So the sine of theta is your opposite over your hypotenuse. Theta is 28 degrees. The opposite is h, and our hypotenuse is 17. To get our hypotenuse, to get our height, the h, the opposite there, we are going to just multiply by 17 on both sides. By doing that, we are getting our variable by itself, so we'll be left with just that h value that we're looking for. And to the nearest foot, we end up with about 7.98 or so we're going to round that to the nearest foot, which should be 8 feet. So we would say that our stairs are 8 feet tall. In the third question, it says that you are flying a kite with 20 feet of string extended. So we're going to label that string as 20 feet. The angle of elevation from the spool of string to the kite is 41 degrees. So from the spool of string, that's what's in the girl's hand, would be your line of sight, your horizontal line, and the angle of elevation, so above that horizontal line, would be 41 degrees. We want to know how far off the ground is the kite if you are holding the spool 4 feet off the ground. So I want to know from the kite to the ground. We're going to kind of have to do this in two parts because the height from the ground to the spool is 4 feet, but from that point then, 4 feet above the ground up to the top of the kite is what we don't know, so we're going to label that as our x. We have enough information here, though, to use one of our trig ratios and solve for that amount. So 41 will be my theta, which means my x is the opposite, and 20 is the hypotenuse. We have this right angle being formed right here. It's also with the ground and to the top of the kite, but we're going to be focusing on this one from the horizontal line of sight up to the kite. We're going to say that since we have our opposite and hypotenuse being used here, we're going to use the sine function again. So sine of theta is always your opposite over your hypotenuse. And in our drawing, we can see that our theta value is 41 degrees. Our opposite is our x that we're solving for, and our hypotenuse is 20. So to get our x value by itself, we'll multiply each side by 20. What happens is that our 20s will eliminate, and we are left with our x over here. 20 times the sine of 41 gets us about 13.1, and that would be feet. Now the question says, how far off the ground is the kite if you're holding it 4 feet above the ground? So we have this distance now saying, well, this is 13.1 feet, and then the distance from there to the ground is another 4, then the kite is actually 17 1/10 feet off the ground, because we're adding that 4 and 13 1/10 there. Next up, it says you are standing near the Washington Monument, which is 555 feet tall. The angle of elevation from your position to the top of the monument is 35 degrees. So how far are you from the monument? So we need to kind of label this picture a little bit. Our monument is 555 feet tall. And we're going to say that maybe you're way out here looking at the monument from afar. Since we know that the height is 555 feet, and we know that you are looking up at an angle of elevation of 35 degrees, we can see that we get a right triangle being formed here from the top of the monument down to the ground with our 90-degree angle here. So we want to know, how far are you from the monument? Well, that would be this distance on the ground here. How much further would you have to walk to get there? So we're going to label our 35-degree elevation angle there as our theta, which means the height of 555 is our opposite, and our x is actually our adjacent this time. It's right next to that angle theta. So we're going to be using the tangent function to help us, because tangent is always your opposite over your adjacent. Our theta is 35 degrees. The opposite side is 555, and your adjacent is your x. When your x is in the denominator like this, one of the ways that's helpful to solve is to set this into a proportion. You can put any number over 1 and it does not change the value. So now that I have two fractions equal to each other, I can just cross multiply this to solve. 1 times 555 is just 555, and I would multiply x times the tangent of 35. Well, that's just a number. We don't know it yet, but we can just divide both sides by that tangent of 35 to get x alone at this point. And that will leave us with our value of about 792 6/10 of a foot, equaling our distance from that monument. Finally, it says from a point on the ground 500 feet from the base of the building, it is observed that an angle of elevation to the top of the building is 24 degrees, and an angle of elevation to the top of the flagpole on top of the building is 27 degrees. So that smaller angle is 24, only to the top of the building. So if I wanted to figure out what's the height of the building, I'd be using the 24. But this question says, find the height of the flagpole. So I'm just going to be focusing on that angle of elevation from the ground to the top of the flagpole. And the top of my flagpole is going to be that distance of 27 degrees. So we have 27 degrees here, and we want to know, how tall is this? So up here will be our height of k. So we have our opposite angle and our opposite side and our adjacent side to the theta of 27 degrees first. That's going to get us that whole height that is labeled as k from the ground up to the top of the flagpole. So we're going to do this first and set up our tangent of 27 will equal our k, which is our opposite, over our adjacent, which was 500. We'll multiply both sides by 500, and we are left with 254 8/10 of a foot to equal k. So that is our whole height from the ground all the way up to the flagpole. But we want to know, well, what is the height of the flagpole? So now we also need to figure out what is going to be the height of the building. So I'm going to erase what we have here. We are still sitting 500 feet from the angle up to the building, but now we're saying to the height of the building, the angle of elevation is only 24 degrees. So now I want to find, well, what's our h? H is now going to be our opposite side. Our adjacent is still 500. So this time we're going to say the tangent of 24 will equal our opposite h over our adjacent 500. Again, we'll multiply by 500 on each side, and that's going to get us 500 times the tangent of 24 degrees this time. And that leaves us with an h value of 222 6/10 feet. So that means that this part of the building, or the height of the building, will be 222.6. But the height all the way up to the flagpole is 254.8. So if we want to find how tall is the actual flagpole, we just have to find the difference there and subtract 254 8/10 minus 222 6/10, to see that our flagpole will equal a total of 32 and 2/10, because that is that difference between the amounts of the height of the building up to the height of with the building and the flagpole.